All right, so let's continue. So we're looking today at systems of equations, meaning two equations that use the same variables. They both use y, they both use x. So if we graph them on the same coordinate plane, if they have a solution, it's the point where they cross. So I want to talk about the second part of our subject today, which is types of solutions. So there's three possibilities. We could have one solution. So that's what we just looked at in the previous video. One solution, one point of intersection. So that's the most common case. Obviously, if you draw two lines and they go forever in both directions, it's very likely they would cross each other. And where they cross is the solution, and it makes both equations true. But there are two other possibilities. So let's look at those other possibilities. Sorry, let me get this situated here. So here's another system of equations. It's a system of equations because we have same variables, two equations on the same coordinate plane. So let's graph these like we did before and let's see what happens. So this guy has a slope of -3, so we'll put it as -3/1, meaning it's going to go down 3 right 1. And it has a y-intercept of 4, or 0, 4. Our other equation also has a slope of -3, or -3/1, and it has a y-intercept of -2. So let's graph them. So put a point at 4, go down 3 right 1, down 3 right 1. So there's our first line. So that's the first line. And so we're looking for a point where they would intersect, and that would be the solution. So here, graph the second one, we have a y-intercept of -2, and we're going to go down 3 right 1. And I'll go backwards, so up 3 left 1 to get a point behind it. And we'll graph this line. And now what you may notice is that, what you may notice is that these lines are parallel. They both have the same slope, so they both move in the same direction. And so they will never cross. So even though they extend infinitely in both directions, they will never cross. So we call this no solution. So this system of equations has no solution. And that happens when the lines are parallel. And we can generalize as well that they have, we could say the lines have the same slope. So they both had a slope of -3, right? So they both go in the same direction. So, and different y-intercepts. So because they have different y-intercepts but the same slope, they start in different places, but they move in the same direction, so they'll never cross. And so therefore, they would have no solution. So there's no value that I can plug in for x and y to make this true that also makes this true. Now, there's lots of solutions to this line. All these points are solutions for this line, and all these points are solutions for this line, but they have no solutions for both lines together. So each line on its own has many solutions, but the system itself has no solutions. So one possibility is that you have one solution, that's when lines cross, no solution when they're parallel, and then there's a third possibility. So a third possibility, let's look at that. So here, let's graph these lines. Notice this has a slope of -2/1 and a y-intercept of 3, and this other line is exactly the same line. So it also has a slope of -2/1 and a y-intercept of 3. And so as you might imagine, as I graph the first line, and then I go to graph the second line, down 2/1 again, how many solutions do you think we have? So there are two lines exactly on top of each other. That word is called coincide, meaning that they're right on top of each other. And so we call this infinite solutions, or infinitely many solutions. It means every point is a solution. And so the lines are the same, or you could say the lines coincide is a word that is often used, and just means they're the same line. And so we could see they have same slope and same y-intercept. So of course they're exactly the same. So every single point, right? This is a point to both because it works in both. This works in both. This works in both. This works in both. Every single point would make both equations true, right? If I plug a number in here and a number in here, I would have to plug the same number in here. So of course it would be true for both equations. So 3 possibilities, 1 solution. Let's summarize at the bottom here. So you can have 1 solution to a system, which, right, might look like this. Right, here's one line, here's another line, and this is the point of intersection. So this would be the 1 solution, that point. Or you could have no solution. Right, if this is my x and y axis, and I have 2 lines that are parallel, then of course they would never intersect. That's no solution. Or you could have infinite solutions. Oops. You could have infinite solutions, which just means that the 2 lines are actually the same line. So this line, and then there's another line directly on top of it. I'll show it by putting just other arrows here. And so those are the same line, and that's infinitely many solutions or infinite solutions. So those are the 3 possibilities. So when you're solving a system of equations, right, we're looking for a point where they cross. That's the solution, right, like we have here, or like we have here. But the possibility exists that the lines are parallel, in which case there's no solution, or that the lines are actually the same line and then there's infinitely many solutions.